So hello everyone, welcome to a new video. It's been a long time I didn't make any videos, but I've been thinking about myself and the things that I need to do first before I get to make another video. But today we have an exclusive course. I don't know for how long it will take, but I'm just gonna make sure I'm gonna cover everything that it's on there. Maybe I'm gonna split it into parts, but it doesn't matter. So as you have read from the title, it's gonna be about data structure, and in C, of course, C programming language. I'm a big fan of low-level programming language. Let's say Rust, C, C++. I don't know, but yeah, C and Rust are my favorite you know, programming languages. So before I start or go any further with data structures, you need to know and you need to be aware of the data types in C. So why do we need data structure? We need to know first that the prime data types, I call them prime, but you may find another name for them. There is integers, float, char, and then you find double, long, whatsoever, double, long, I don't know, something like that. But the main things are these. The main ones are these, the prime data types. But sometimes, let's say, for example, we need to, create a new data type that contains, let's say, for example, let's have a user-defined data type, a user-defined data type. Sorry. Let's say, for example, let's say I take student. Student is a data type, and it has, let's say, integer that it's an ID. It has char. When I write this asterisk over that, it means a list of characters. It's sometimes referred to pointers and those things. I don't want to get into that now. There is a video I made about strings. You can go and watch it and you will have a clear idea about that. So let's say name or full name, it doesn't matter. Let's say full name. And what else? There is also another integer, or let's say a float, that it's a mark, but I want to keep things simple, so I'm going to just use well, let's say keep it float, because like this we're going to have all the data types united in one data type that it's so these ones I want to indent them. I don't know how to do that here, but I want just to add an extra space here, and then let me copy that character. I don't know, sometimes doesn't go the way we want it to go, but let's make it this way. So we have a beautiful indentation in here, so the color, let it be red, something like that, for the char here, so we can distinguish between the data type and the attributes of our data type. So for now we have a student, okay, but I have student, it's fine. I can use a struct, and then let's say I can make a struct over here and then call it student, and then I will you know um, just say code, not this one, but this one, code goes here, because it's gonna be the same thing I have written just now, so there is no need for me to rewrite it's the same thing, I may say, but this is not what we're going to talk about. There are some, famous data structures they always talk about when it comes to C programming and these things. There are the linked lists. What are the linked lists? Okay, so now I have talked about data types, data structure, whatsoever. Somehow I didn't really talk about it, but this is a good, I believe it's a good start. If it's not, yeah, you can criticize me. I accept constructive criticism. So let's say data structure, linked lists. So let's talk about linked lists. Okay, linked list is for other programming languages. If you have tried, for example, Python or there is Python, Java, JavaScript, all other programming languages, even C. There is some data type that's called array. Okay, array. So in array you have element one, and then you have element two, and so on. Okay, this is an array, and you can go from element one, if I may say. Let me just no, I want a circle, man, just a circle. Yes, it says just type in O from element one, and let's medium at least. From element one you can go to element two, and so on. This is the whole idea of linked lists. Okay, you can tell me that yes, there is this data type in C, and it's actually what we call lists, or maybe arrays. I'm not sure, but you could just go by integer and then you name it, let's say numbers, for example, and then you say 20, and then inside that 20 you can insert 1, 2, etc. I will tell you that this thing is truly a list, and yes, you can navigate through this list from like numbers 0 is 1, and numbers 1 is 2, and so on. Yeah, that's true, that's correct. But what if I want to add a number to this list? I will run to something called stack overflow or buffer overflow. Depends on the on where the variable is defined, but most of the times it's on the stack. These things are defined in the stack. Correct me if I'm wrong, but I'm saying what I know for the moment. But let's say yes, for others, like characters, like name, you say 25, and then you have, let's say my name is you have Y, you have A, and so on. My name is Yasser, by the way. So if you try to add more than this, you will run into buffer overflow. This is something I'm sure of. Okay, and this is a problem with C programming or the C language. It's not memory safe. Buffer overflow, it's simply the exploit, or like it's a problem with the C programming language because it's not memory safe, where you are not meant to navigate to a certain place in a memory, but you did. Okay, that's the problem. Like let's say you have a table, and let's say this table you have only access to the two firsts only. Like here you have access, you have let's say authorized, unauthorized, and unauthorized. So let's say you are only allowed to go through only these two cells, but with buffer overflow you can get access into unauthorized places, and then you can insert some shellcode. And the shellcode, when I say shellcode, is something like I'm not sure if it's this one. Yes, and like you're right. I don't know if you have ever seen that. There's no F, there's no D. There's always hexadecimal letters, and let's say 3 and something like that. I don't know. I'm not sure. It's not that I'm not sure, but somehow like that. So yeah, this is it. This is the buffer overflow. You insert some code in some certain place in a memory that you're not authorized to do it, or you don't have access, or normally or usually you don't have access to that place because you can alter the software behavior. So this is the buffer overflow. So what we say here is that we cannot add more characters to this list. We cannot add more numbers to this list, or elements in general. But the linked lists, it's something different. It's like the other programming languages. What I mean by that is, like, for example, if you want to add an element, let's say we are in JavaScript now, let's say JavaScript. I don't know if you are experienced with JavaScript or not, but it doesn't matter. I'm gonna write some code here. Let's say array, and then this array I have 1, 2, and then I decided to add more elements. Like I decided to add the how we call it, the 3 number. Okay, yes. I just do this, and then at the end I will have the array. The array will be something like that. If I do like console.log, then array, I'm gonna have at the end 1, 2, 3, and there is no problem with that, and everything is fine. In Python, it's the same. It's also you have an array which is a, let's say for example, and then 1, 2. Then you want to add. I believe in Python it's also push. I'm not sure of that, but we can try that now. Okay, let's go Python 3. Let's say a is 1, 2. Okay, now I want to add push 3. Not sure. Traceback list push no attribute. Okay, so it's not push, it's add. I'm not sure how, but okay. Append, yeah, append. Yeah, I'm sorry. It's been a long time I didn't, you know, work with the Python programming language. So I believe append takes like an element and then you tell her like where to put it. I believe I'm not really aware, but no, it automatically adds it to the end of the list. Yeah. So 1, 2, 3. So it's not push, it's append. Sorry. And so on with other programming languages, but for the JavaScript, I'm well aware of that. Like I mean, like last time I coded in JavaScript, it's not longer than a week. So yes, this is it. Now, when we want to print out the content of A, we have 1, 2, 3. So in order to achieve this, and yes, and before I go to that, not just adding, removing 2, which is pop in here, I guess. It's pop. It's gotta be pop, yes, pop. So yeah, it says 3. When I wanna write A, it's like 1, 2. So we have removed the last element, and from the JavaScript, I believe it's also pop, and we can also try that, and we can know exactly. Just open the console in here, zoom it a little bit, and then let a array, as I said before, to 1, 2, then array not dot push, then say 3. Then now if you ask for array, you have 1, 2, 3, and then when you want to pop the last element, no, sorry, I could have done better. Pop, and now we have a 3, and if you ask for array, then now you have only 1, 2, as you can see in here. So this is the dynamic of a linked list. Like this is only like the bare minimum that you can do in a linked list, and you can do these things without running into a problem. So this is the main idea behind the linked lists. Okay, so for us, what we try to do is like let's say we're not gonna take the challenge into a hard and complex thing, because in the new or modern programming languages, like you can have lists of like a polymorphism list, or a list that contains variant types of types, let's say of elements maybe. Like what I'm trying to say is like you can have a list in JavaScript that says 1, then a string that says 1, and then a float 1.0. And this is so fine. But for us, we're gonna take only the simplest challenge, which is a list that contains the same type of element, either these or these. Let's say B and N and I don't know, A N A, for example. I don't know what that means, but I'm just like throwing things randomly. Need to add a space in here. Yeah. So, and finally we can add also 1 2. Sorry, where's the comma in here? Yeah, 1.1, 1.3, and so on. This is the types that we're gonna cover. Like only one is the same data type for for each or every other element. So for now, if we go back, we have talked in here. I believe this is a good way to illustrate things. I hope so. So for us, as I said before at the very beginning of the course, we have only integer float characters. And then we need to bring new data types. So in this data type, we want to have a certain data type that um, you know, I can browse from the first element, the second element, and from the second element, the third element, and so on. We have a third element. We can go with this, okay? Third element, and so on. And if the third element is the final one, we need to put a stop in there. So we're gonna say it's not. There is nothing after that, okay? So I can change this to another color, which is red, which means dead end. So in order for us to do such a thing, let's say we need to bring this data type in here, and we need to clarify things about this data type. I'm gonna change the shape in here. I will change shape. Uh, let's let it be just a square, and then I'm gonna make it like a rectangle. And this data type, it needs to have a, let's say we're gonna call it a node. And then in this node, what we have is the value of a node, of course. And also we have the a pointer to the next value. And that pointer needs to take the same data type as our node. So this is of type node. And the next is a pointer, of course, this means it's a pointer to another element that has the same type as ours, which is node, which is a struct node. We type this struct node because it is how it works. So for now, we can go to labs, C programming, and linked list, I believe. I have worked on something in here before. I'm not gonna touch it for now, so maybe we're gonna need it at the end of the video to illustrate and take the challenge into harder things. So let's start with let's say and then F11. So we have a full screen in here. So in here I'm gonna add a new file, call it linked list. Maybe let's write it this way, .c. So when I open it in here, I first include the include the stdio, because we're gonna need the print function and other functions. Then I'm gonna need stdlib, because I'm gonna use malloc and calloc. If you don't know what these are, I'm gonna explain in a little bit, okay? So we need to do first is to create our data type, which is we're gonna do struct, or like say type def. We have a yes, void, not void, but wait, here I'm gonna call it node type, and then emptiness, not an emptiness, it's a struct node, not node t, but node, holy node. Not a holy, like as in Holy Bible. No, that's not what I meant. I mean, like here node, we have the integer value, and then what we have is the struct node, and it's a pointer to the next value. So in here, if I do this, it says type def requires name. Yes, I didn't insert a name yet. We should not insert a name in here. Type def, we put it in here. So node type. So include the header. stdio is not usually used directly, it doesn't matter for now because it didn't start. We write our main function, and then wait a second, argument variable. I have set it to be void. Void. Let it be integer because so that we can, get to know errors. So if everything goes well, we reply with return 0. I believe I'm just gonna write down 0. Sorry. Yeah. Wait a second. Yes, 0. So yeah, if everything goes well, we return 0. If something goes bad, we return something else. So what we do is we have defined here our data type, which is node or node t, doesn't matter. So for now, what we do is we try to create a linked list. So in order to create the linked list, let's create a function that returns a pointer to a node type thing. We say create linked list. So in here, what we do is we create this function, and then what it does is it returns a node t. We're gonna cast something, and here we're gonna use a malloc that takes size of node type, of course. So what happens now is I ask this function, which is create linked list, to create a linked list. And in order to create a linked list, we need to focus on one thing. Every or each linked list has a point where it starts, so we call it the head usually. So here I'm gonna write down between parentheses head. So this is the head. In order for us to create the head, yes, we need to call this function. So this function, what it does is it returns what? It returns what malloc returns. So if I somehow like get definition, let's say let's go to the cheat sheet so we can see here how to get the definition of from the LSP, which is the language server provider. So LSP references, definition type and declaration, leader T and yeah, leader D. So I go in here, I go to this one, and then do something like that. Okay, let me just undo what I have done and get definition. Second. So we're back. Okay. Here yes, I brought the the library functions manual. Malloc, what it does is it returns a void type, but what it does underneath is it goes to the memory and free some memory space, and it frees it according to the size that you have declared in here, and it returns also a pointer just for your information. This is an asterisk over here, so it returns a pointer. So yeah, the malloc function allocates size wise and returns that pointer to the allocated memory. So this is what we need for now. So yes, and I believe we can go in here now, and then if we want to create a new list, so we say new node t and the head of the list, and then what we do is just create a free space for this linked list. Okay, so I was thinking about something else at the same moment, sorry, but I believe we don't need to do what I have been thinking about. So we create a new linked list. So now we have a linked list, and our linked list, believe me, when we do this, it's just like going in here in this software in here. I bring a new let's keep the blue new circle like this, and it has nothing inside. So if we want to put a number for inside, let's say 15 or 16, let's say, for example, well, what I'm gonna do is like just head and then put, like as you see here, value. So value I'm gonna put inside 16, as I said before, and now I have 16 inside. So now we have created the head of the list. Now we need to make sure that this list, or this head of list, let's make sure that it is the head, and after it there is nothing else. So how we do that? We go to head, and then we do an arrow, and then the next thing we know about is next. The next point that kind of points to, it's null. So there is nothing after. But I believe it is tedious if we keep doing this each time we create a linked list. I believe we can include in here an integer value, and then for the next thing, I believe we don't need a next because it's just a head. I'm gonna put in here node type, let's say head variable, which is a pointer also. And then in that head, I'm gonna put value, insert the value over there, and then for the next thing that you know is null. So there's nothing after that. So we do return our head, and it's fine for now. So I'm going to delete this line, and in here I need to insert my 16. And then everything is going well. So for the next thing that we're gonna do is the display function. We need to display our linked list. Display. I'm just gonna write display, and what it does, it takes the head node t pointer ahead of a list, and then what it does is it we're gonna create a temporary variable here, and then as long as that temporary value it's not null, we keep going on. So what we're gonna do is we're gonna insert the print function in here, then we say I don't know, I'm not sure what to write in here, but let's say element or list element is the, and then we write in here temporary dot but for the temporary thing I'm gonna put the head, of course, is value. Of course we're gonna put the value, and then what I do is temp, it's head, not just head, but the temp, and then next. So we assign the next node to the initial node, and so on. So we're gonna do is like we keep flipping, like from this, let's say this is the point of start and this is the next thing. So I set this, I changed the head to this point, so now I know I'm here and I need to go in here, and so on until I reach the null. When I reach null, there is nothing else to be found. So yes, now I believe we have the display function ready to use, and yes, I believe it's a good time to try it, give it a try. So if I just want to play display my head, display the function, of course, first list, or let's say list one here, so should not confuse people. List one. For the rest, it's fine, I believe. So now let's say I'm gonna change this to here, and yes, like this. I'm gonna insert an horizontal terminal, and then I'm gonna type gcc linked lists, output to be linked lists, and now it says that the main function error related ld return 1 exit status function start gcc linked list c. Now I believe there's something wrong in here, so I need to exit the terminal and go back in here. So if you check the stdio, everything is fine, 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 fine. Main, integer main, argument c, argument v. It's fine in here, fine in here. There's nothing wrong. There's only user lib linux gnu or ssc in the function start and defined reference main. Ah, yes, yes, yes. I know why this happened, because we didn't save the file. We need to save it. So now it's saved. So now if I go back in here and do this, yes, it's fine. So what we do is now is like run the linked list. So we have list element is 16, and we have these percentage character here because it's due to my terminal. It's not something, it may not appear in yours, but I know how to make this disappear. It's just by adding the return to a new line. So if I go back to the terminal, I know I need to build it again. Now it's gone. So now we have a linked list that starts at 16 and ends right there. So if I want to add another element, so how can I do that? So we need to make sure that the add function takes always into consideration the head, okay, the head of the list, and then what it does is it also takes the value to the next point of the next point. Then we start writing our code. So there is a philosophy in here that we need to be aware of. Let's say I'm in this point in here. So yeah, sorry, I'm back. So here, as I said, let's say we are in here and we decided to add a new element, which is this one. So we added just right here, but we know that we are here and the next thing gonna be in here. And each time we are inserting an element to the list, we have only, or we are only aware of the head. So the head in here, if we are at this point, we know where the next element will be. It will be here. But if we have a list that contains two elements, so the next element will be here in this place. I don't know if you see the complexity in here, but the thing is a little bit complicated, but the solution is very simple, of course. So we need to keep track or make sure that the next element, the next element is always null, which means if I start in here, I need to check the next element. If it's null, then we add it here. If it's not, then we don't add it here. We go to the next element. If it's null, we add it here. If it's not null, we add it in the next of the next value, of course. So in this case, it's null. So we add it to this place. So if I want to add the fourth element, I just go this like this, copy paste, and what I do is I add the new element, and okay, here, and then what we have is, and this link in here, it's broken. So the next we go to this place and go up in here. So this is how it happens. So in add, what we do is we check. We always have that node temporary variable that it's the head. Then we say as long as yes, as long as the temporary value is not null, keep going. So we keep exploring the list. So we take the temp and we check. If the temp next is null, then we add it here. So what we do is we change the next temp next to the, to the next value. And here there are two paradigms. Okay. What we are going to do is that we're going to create a new place in the memory, and then we need to put a value inside the value of the value attribute of that element in the memory, and then we're going to set its next to null. So without rewriting the code, we can make use of our previous our previous function, which is create linked list. So I can go in here and say create linked list, and then add the value in there. And this all makes sense. Why? Because if we go here, sorry, the here in here, the element that we have added in here, it can be also ahead to another list. Okay, so it doesn't matter exactly what the rest is. Doesn't really matter as long as we still have the element 4 in here. So we wanted to add the element 4, but what I'm trying to say is, like, at some point, create linked list, all it does is it creates a new head that points to the value that we want to. Of course, it's going to be some value in here, and then the next thing it points to is null. So this thing in here alone can be another linked list. So that's why it makes sense. That's why it's logical. I can go and rewrite the same code, but remember always the main principle, or the code that you should never break in programming. Don't repeat yourself, especially in programming languages like C. It's always complicated to repeat yourself. It takes a lot of time, effort, energy, and consistency. So in here, what we have done is we have been going through the list, exploring it. Okay, go in here, then go in here, then go in here, and if in here the next thing gonna be null, just put this in here. So for now we are just looping infinitely, and this will never stop. Why? Because we are not setting temp to temp null. Not null, I mean like next. So what we're doing here is, like, we exploring, and then when we find that the next thing is null, we create the linked list, and then when we set the temporary value to its next value, which is, I believe, this thing in here, should happen otherwise. I mean, like, because let's think it through. If I put in here the next value will be something like create linked list, you know what's gonna happen in here? It's gonna create a new element at the end, and then when it comes to check if the next thing is null, what happens is it starts again, because the next thing will be the last thing that we have created. So it's gonna keep repeating itself, and in order to stop that, we need to stop the function or the loop in there. So we either type in break, or we can just say return and stop it right there. Because if you don't, it's gonna keep looping infinitely, because it's gonna add element 4, it's gonna add element 4 infinitely. And yes, so we need to say break in here. So when it happens, just break over that. So if we go to list 1, so I'm gonna add an element to list 1. I'm gonna add 12, and then I'm gonna display list 1. I believe I need to save it, and then let's go sorry, nope, focus in here and go in here. So we need to compile it. Everything is fine. Now I need to run it. So it's a list element is 16, then list element 16, and then list element is 12. And why this happens? Because we ran the first function in here and it gave us only 16. Then we run it for the second time, it gave us 16 and then 12. So now our program or our software is running very well. We need to add some decoration. Print Sorry, this is a character and this is a list, and not print, just print function. Okay, and I believe this one should not be in here. I need to somehow alter it, so it's gonna be something like this. I believe this is gonna work very well. So if we just go in here and compile that again and run that again. So yes, it says list element 16, and then I forgot to add the return to a new line character. GCC and linked list. So yes, now we have the first print and the second print, and it's going very well up to this point. Now if we try to add another element to list 1, then 16, another 16, let's say 21 or 20, just 20. Sorry, I'm gonna display it. Display list 1, and I'm gonna save it. Go back in here. So yes, we have the very beginning 16, 16, 12, 16, 12, 20. Even the order of putting the numbers is set correctly. So for now, I believe we have finished with display. There's the remove part, and it's a little bit complicated because believe me, when you wanted to remove something, what you're gonna do is you start by looking for the element that you want to remove, and then when you find it, what you're gonna do is you are gonna make sure that the previous element will be the last element, which means the last one that's gonna points in here. So you have 3 cases. If the element that you want to remove is the first element, then you need to change the head. In the head, you need to change it. The head gonna be this one. If you need to remove the last element, you need to change the element, the last element. The last element is always the element that points to null, points to the next. Its next thing is null. So that thing you need to worry about too. And then you have another thing, which is if it's in the middle, which is easier than the others, because you have the previous and then the next thing. All you do is remove this one and you link the head with the element 3 or element 2 with element 4 and get rid of element 3. So this is how it happens. So remove, I believe I'm gonna add remove for now, or let's meet in another video when I specify a video especially for remove, because it has 3 cases and I need to explain it very well, and we have gone for like 43 minutes. So thank you for watching for today. We're gonna meet up again in another video where I explain the remove and maybe insert functions. So see you.